experiment for K factor. Okay? So K factor, head loss, the velocity is lost, pressure is lost due to the various pipe fittings. So pipe fittings are very important and we should know the K factor for each pipe fitting. So today's our objectives is to find the head loss through a 45-degree elbow. So here the 45-degree elbow, the same procedure, just we need to connect manometer here and here at inlet and outlet. Okay, so this is a 45 elbow, this is 90-degree elbow. Okay, so there is a, so here you can find sudden reducer, here you can find sudden enlargement. So water is flowing through like this, so this is sudden enlargement. So diameter is given, diameter is written here. So here also we'll find a 90 bend. Okay, so here we need to put the tab. Okay, so this is 45 elbow is there, 45, yeah, this is 45 elbow. So these are various pipe fittings used. Sometimes you use ball, wall, sometimes you use gate wall, sometimes you use globe wall. So today we are going to learn the K factor for gate wall, K factor for globe, K factor for 45 elbow, K factor for 90 elbow. So already we studied friction factor for this pipe. Okay, so the procedure is start the motor. So first we are going to study a 45 elbow. So connect the manometer here. So remove from here. So I will connect the manometer. So how to connect? Keep your hand here and press this, or keep your hand here, press this down and press it inside and release it and pull it little, check. So again press this by one hand and put it here. How to remove? Press it back and pull it. Okay, so press it and push and check whether it is connected or not. So connection is done. Mercury level is same. So we start the electric pump. Okay, immediately start this wall fully, open this wall fully, and this wall. Okay, now keep this open and check the ear. Yeah, there is a ear. So let this ear go. Now open this and check the ear for here. There is a small bubble. Now almost there is no ear. Now keep this along the flow direction. So water is flowing like this. So keep this along the flow direction and you can see the difference here. Okay, so take the first reading for completely open. Okay, take H1, H2. Then close little, take H1, H2. Measure Q for 5 liter or 10 liter and time for that. Okay, so after this, take 4 readings for 45 elbow. After that, just close it. After that, close it and open this, and we can choose what is given to you. So 90 elbow, I will skip this and I will go for gate wall. So keep your hand here, press it and check it. There is no deflection. Why? Because water is flowing to this pipe, not from this pipe. So we have to close this wall and open this wall completely. Open this wall completely. Both walls should be open. Now we are measuring for this. So there may be a ear because we transfer the pipe. So there may be ear. So remove this ear. Keep this open and you will find the deflection there. Lot of pressure drop. Now remove the ear. Okay. Now for this, if ear is gone, close it, and measure H1, H2. First reading, the wall is completely fully open. Measure H1, H2. Measure time for 5 liter water. We choose 5 liter water because this flow is less flow. Okay. Now second reading. Not from here, from here. So open this, little, close this, and you will find deflection here. Close little, and you will find deflection here. See now, take another reading. Okay, third reading, close it. Take this. Close this, so take 4 readings. After that, close this and connect to globe wall. And here you will find what is the difference between globe wall and gate wall. So globe wall means inside the area is increasing, decreasing. So this wall is used to control the flow. This wall is like a gate wall, it is gate open and close. So to on and off, close the water. This gate wall is used. This globe wall is used for controlling the flow. Okay, so this difference may be asked in theory exam. What is the difference between gate wall and globe wall? Or this may be asked in interviews. Which wall you will select for this application? Okay, so here we will take 4 readings for gate wall, 4 readings for globe wall, and 4 readings for 45 elbow. For 90 elbow, the flow rate is very small and there is no deflection. So we can use a 90 elbow here or that machine, gun, another machine. Okay, so here also we can use for 90 elbow. So where is 90 elbow? Here is 90 elbow, but there are 2 elbows. Okay, so you have to connect here and here. So there are 2 elbows. This is sudden enlargement. If it is asked to find out K factor for sudden enlargement, connect the manometer here and here. The same procedure. Start the pump, control from here, outlet. Okay, so this is the inlet, water is coming from here. So we can find out for what is given, what is asked to you. Here also we can see. Here also we can find out K factor for bend, K factor for elbow, bend, very big bend. This is small bend, this is big bend with a large radius. We can find out the K factor for that. We can find out the K factor for wall. We can find out the K factor for 90 elbow by connecting this. We can find out the K factor for 90 elbow with a different size. Okay, so any one it is given to you. Any machine it is the same operation. How? Start the machine, open this wall, so water is flowing. Now this is a water manometer. We can use this directly to mercury manometer also. So if it is there mercury manometer, if water manometer is calibrated, we can use that. Okay, so here we can find out. So we'll come back to that experiment again. So first we will take the readings for will take the readings for gate wall. So I will completely open it. So I will completely open these walls. And now there is no here. And now take H1 and H2 and measure the time. Okay. So at last, close all the wall and switch off the pump. Okay. So please come, this student come here and take the reading H1, H2. Yes, please come. So this is a gate wall. Stopwatch is there. Is there stopwatch? Yeah.